Hi, and welcome to Unit 2. Today we're going to cover Chapter 5, Solving for the Unknown. One thing you'll notice different is all of the homework will be an online assignment, just like the activity, but this time you'll fill in the blank. And so after we cover Chapter 5, I'll actually cover some of the homework. So lucky for you, you tuned in and you'll get some homework done for you. And you'll find that on the Unit 2 drop-down bar on the Chapter 5 homework. But what is Chapter 5? It's solving for the unknown, and it's building upon what we had studied in the first unit. And one of the big things about Chapter 5 is there's a lot of vocabulary. And you'll see in this equation right here, just right there, I already used one of the terms. We have an expression which is the 6a plus 3. And what's nice is expressions don't have the equal sign, but when you have that equal sign, you actually then have an equation, and so together they create what you're trying to solve. And I also had up here the formula. A formula is an equation that expresses a principle or a rule, such as simple interest. You have your principal times your rate times your time, and so that's kind of what a formula is. Once we get into it, we'll cover a lot more formulas in Chapter 10 or so. But how do we deal with solving for the unknown? How do we find that variable when we know the constant? And what is our variable? Our variable is our unknown. What is our constant? Things that we do know. We know, 21. We know this is 3. So trying to solve for that and understand what we're solving for. So we're going to look at what they call the opposite process rule. And that means we learned in the first unit that the opposite of addition is subtraction and vice versa, and the opposite of division is multiplication. So how can we use that to our benefit to figure out variables? One key point that we need to pay attention to on all of these are if you do it to one side, you have to do it to the other side. And so let's look at a couple simple problems in subtraction, addition, division, multiplication, and with variables. How are we going to do that? Well, if I want to figure out what my variable a is, I have to figure out that I see that there's a constant, and I know what the basically summation would be. So a plus some number is equal to 50. So I want to get my variable all by itself. So how would I do that? Well, I have to get rid of the 8. So if I want to get rid of the 8 to make it 0, I subtract 8. But if I do it on this side of the equal sign, I have to do minus 8 on the other side of the equal sign. So, what would I have? A would then equal 42. And can I double check that? Sure, let's plug that in. 42 plus 8 does equal 50. So that is correct. Okay, so what happens over here? So now I don't have an addition sign, I have a subtraction. So to do the opposite, I'm going to add. So I want to get b by itself, so I want to add 50, and I have to do that on both sides of the equal sign. So b, these cancel out, so I have 0 over here, and I've got 50 plus 80, so I've got my 0, 5 plus 8, carry that, 130. Can I plug this back in and double check? Sure. 130 minus 50 equals 180. Now division. How am I going to get g by itself when I have 7 g's? Well, I can divide it by 1/7, but without carrying the 1, I just put it right below. So if I divide that by 7, I have to divide this side by 7. So g is equal to 5. The same, if I have a fraction, I need to multiply. So I need to multiply this whole number by whatever the base is, the denominator. So I have a 5. If I want to multiply that by 5 as well. So v equals 350. So that's predominantly the opposite process rule. What happens when we face a little bit more complicated equations, some that have multiple steps? So this is a multiple process rule. Well, first we want to get the variable by itself. So how do we do that? Well, first I have to get rid of the 2. So I'm going to subtract the 2, and I have to do it on both sides. So I've got h over 4 is equal to 3. Now I got to get h by itself. How would I do that? Well, I have to multiply it by 4. So I have to multiply this side by 4. The 4's cancel out. I get h by itself. H equals 12. And I can actually plug that back in. 12 over 4, which reduces down to 3, plus 2 does equal 5. Okay? Now there's a thing they call the parenthesis rule, and basically what they want you to do is they want you to do the parenthesis first and then work out the problem from there. So if I had 5 parenthesis p minus 4 equals 20, I couldn't just divide by minus 4 times 5. I have to actually work it out. So 5 times p is 5p. 5 times minus 4 is minus 20, equals 20. So now it's my multiple step. So now I can bring the 20 over as a positive 20. Positive 20. That cancels that out. So I have 5p equals 40. Then I take a 5 from each side. So p equals 8. Can I plug that back in and check it out? Sure. So 8 minus 4 is 4. 4 times 5 is 20. So that's how you do variable equations. What happens if we hit a word problem? Well, the book gave you 5 steps to do. And the first step I mess up all the time. And it's read the problem very carefully. If you have to, read it multiple times. The second step is, what are we solving for? What are we trying to figure out? And in each of these word problems, that question keeps on arising because we want to know, what are we solving for? Third question I think is kind of maybe the hardest and where people sometimes get lost is, once we know what we want to solve for, and we have to designate a variable, well, what happens if we have 2 unknowns that we're trying to solve for? Well, what you need to do is you need to put the second term, the second variable, in the same terms as the first one. And how we'll do that is we'll demonstrate it by doing a couple of the DVD practice problems. So I'm turning to, in Chapter 5, I'm going to look at page 122, Practice Quiz 5-2. And we're going to set up our equations, we're going to solve them based off of these rules, and then we're going to double check them. So what I'm going to do is first read the question. It says, an LLB sweater, bean sweater, was reduced $30. The sales price was $90. What was the original price? So what is our unknown? Okay, so what are we solving for? Well, they just asked, what is the original price? So our unknown, I'm going to put it the OP. Our original price is unknown. Okay, so what do we know? Well, we do know that a sweater was reduced by $30 and that the sale price was $90. So our variable is going to be P for price. You can use whatever letter you want. It just works out best for what you want to. And I'm going to come over here, sorry. And my relationship of these variables, well, I know that the price is reduced $30 and it then equals $90. Okay? So what do I need to do? Well, this is a simple addition equation. I need to get my P by itself, so I'm going to add the 30 to both sides. And P equals $120. So the sweater was 120 bucks. I hope it was worth it. It probably shouldn't have been a Christmas ugly sweater party sweater, hopefully. Let's try another one. Let's try number 2. Kelly Boyle budgets 1/8 of her yearly salary for entertainment. Kelly's total entertainment bill for the year was $6,500. what is Kelly's yearly salary? So we're looking for Kelly's yearly salary, okay? So the variables, her salary, and what do we know? Well, it says, and we'll draw a line here, and we'll come down a little bit. And it says that we know that she spends 1/8 of her salary on entertainment, correct? And that 1/8 is equal to 6,500. So what do I have to do to get my S by itself, to get the salary by itself? Well, I got to multiply it by 8. So that means I have to multiply the other side by 8. So salary equals 6,500 times 8. Okay, when I do the math, it's about $52,000. So that's a couple of the practice DVD problems. Let's focus on some of the homework problems now. So I have my blueprint chart, is what it's referred to in the textbook, up. And I'm going to look at 3 of your homework problems, and we're going to start with homework number 12. So it says in 1955, an antique car that originally cost $3,668 is valued at $62,125. So it's now $62,125. Okay? If it's in excellent condition, which is 1 3/4 times as much as a car in very nice condition. What would be the value of the car if in very nice condition? So what do I know? And what do we want to solve? So we know what we know, and we know that excellent condition is actually 1 3/4 times, which is the same as 1.75 times as nice. The value of a excellent condition car, so a very good car is going to be less than that, or a very nice car is what they call it. So let's put it here. What's our unknown? Well, we want to know, our unknown is the very nice condition. So what's our variable going to be? Well, I already put V in for variable or very nice, or depending on what you want to say. But our relationship, let's figure out what is our equation. And we see that they said 1 0.75 or 1 3/4 of the very nice is 62,000. So let's write that down as our equation. So 1.75 V is equal to 62,125. So get V by itself, divide by 1.75, 1.75, so V should then equal about 3550. So that's our price, and that's what you'd want to put into the answer form. So let's go on to another homework problem. Let's check out, how about 18? Once I get there. Yeah, 18 is an equation. That'll be good to work on. 7 times, so number 18. 7 times A minus, what's that? 5 is equal to 63. Well, what do I have to do? Well, since I see the parenthesis, I know I need to start there first. So we have 7a minus 35 equals 63. So then, this is my multiple phase. I want to add that 35 both sides. That cancels out. That gives me 98. So 7a equals 98. So I'm going to divide by 7. Divide by 7. Okay. So I brought that down. 98. 7 goes into 9 one time. I can also know that 7 times 10 is 70, and 4 times 7 is 28, so it's 14. Or I can do my math. So you got 28, 14. So A equals 14. Let's do one more, just because you're actually paying attention and watching these. How about, I don't know, let's do 28. That one might be a tricky one for you. So number 28. I might have to duck down so I can actually write this one. Okay, 28 says Staples sells boxes of pins for $10 and rubber bands for $4. Leona orders 24 cartons for $210. How many boxes of each did Leona order? Check your answer. Hint, let P be pins. So we now have two unknowns. We have pins and we have rubber bands. And they recommended, and I'm going, because I went kind of cattywampus, I want to do a little creative drawing. But we have our unknown. We have pins. We have rubber bands. Okay. We have our variables because we know some things that they told us. They told us that pins cost. So we have our variable. We have our price. So they told us that pins cost $10 a box, and that rubber bands cost $4 a box. She ordered 24 cartons for $210. Okay, how many boxes did Leona order total? So we know that pins are going to be my variable P, and if she ordered 24 cartons, then that means rubber bands is what's left over, so 24 minus P. Okay, now when I actually figure out my relationship, we have P times 10, so you got 10P, and then we're going to parentheses this, and we got 4 times 24 minus P. Now what's that equal? They said it equals 210. So my equation is going to be 10P plus 4 times 24 minus P equals 210. Okay, so I can do some math, and I've got my 10P plus 96 minus 4P equals 210. So 6P, I'm going, because I did the 10 minus 4 P's, I'm going to bring my 96 over, so minus 96, I got 114. 6P equals 114 divided by 6, so P should equal, once I do the math, 19 boxes. So how do I figure out how many rubber bands I have? Well, I plug in my P here, 24 minus 19, so my rubber bands should equal 5 boxes. I can plug those both back in, and they give me the correct answer. So, thanks for sticking it through. That's chapter 5. If you have any questions, just give me an email. Look forward to seeing how you like the new homework format. Thanks. Take care.